Your brain craves nicotine like it craves food, water, or air. Scientists are now testing a vaccine that could erase that craving entirely. It sounds like science fiction, but the mechanism is simpler than you'd think, and it's already being tested on humans. Every time nicotine enters your bloodstream, it races toward your brain in about 7 seconds. That's faster than most drugs. It crosses the blood-brain barrier like it owns the place, locking onto receptors that flood your system with dopamine. Your brain remembers this. It wants more. This cycle is what makes quitting feel impossible for millions of people worldwide. But what if nicotine never reached your brain at all? That's exactly what a nicotine vaccine aims to do. Instead of blocking receptors or replacing the drug like patches or gum, it teaches your immune system to attack nicotine molecules the moment they enter your blood. Think of it as training your body's defense system to recognize nicotine as an invader, like a virus or bacteria. Here's how it works. The vaccine contains nicotine attached to a larger carrier protein. Nicotine molecules alone are too small for your immune system to notice. They slip past your defenses undetected. By binding nicotine to something bigger, the vaccine makes it visible. Your immune system sees this combination and produces antibodies specifically designed to latch onto nicotine. Once vaccinated, every cigarette you smoke triggers an immune response. Antibodies swarm the nicotine molecules in your bloodstream, binding to them and making them too large to cross into your brain. The nicotine gets trapped in your blood, eventually broken down by your liver, and flushed out. No brain entry means no dopamine rush. No rush means no reward. No reward means the addiction loop breaks. Clinical trials have shown promising results. Participants who developed high antibody levels reported significantly reduced cravings. Some stopped smoking entirely without the usual withdrawal symptoms. Their brains simply stopped associating cigarettes with pleasure because the chemical reward never arrived. However, there's a catch. Not everyone responds the same way. Some people produce massive amounts of antibodies, others barely produce any. Researchers are still trying to figure out why immune responses vary so dramatically between individuals. Genetics likely play a role, but the exact factors remain unclear. There's also the question of heavy smokers. Someone who smokes 2 packs a day floods their system with so much nicotine that even high antibody levels might not catch it all. Some molecules inevitably slip through, reaching the brain and maintaining the addiction. For the vaccine to work, the antibody response needs to be strong enough to handle whatever nicotine load comes its way. And then there's something researchers didn't initially expect. The vaccine doesn't just block nicotine from cigarettes. It blocks nicotine from everything, including cessation aids like patches and gum. If someone relapses after vaccination, those tools become useless. The same antibodies that prevent smoking pleasure also prevent replacement therapy from working. Despite these challenges, the potential is staggering. Imagine a world where smoking simply stops being enjoyable, where the physical addiction can't take hold because the brain never receives the chemical it craves. But before this becomes reality, scientists need to solve one crucial problem that could make or break the entire approach. The problem is duration. Your immune system doesn't hold on to these antibodies forever. In early trials, antibody levels peaked around week 6, then started declining. By month 6, many participants had lost most of their protection. Their bodies stopped treating nicotine as a threat worth remembering. This means the vaccine isn't a one-time solution. You'd need booster shots, possibly every few months, to maintain enough antibodies in your bloodstream. That's a tough sell compared to a patch you wear for a few weeks or pills you take temporarily. Compliance becomes an issue when treatment never truly ends. But what if researchers could extend that protection? Some teams are experimenting with adjuvants, special compounds that supercharge immune memory. Others are testing different carrier proteins that might trigger longer-lasting responses. A few labs are even exploring genetic factors, trying to predict who will respond best before vaccination begins. Cost is another barrier nobody talks about enough. Developing vaccines is expensive. Manufacturing them at scale, distributing them globally, ensuring cold storage throughout the supply chain, all of this drives prices up. For a vaccine targeting addiction rather than infectious disease, convincing health systems to foot the bill becomes complicated. Insurance companies hesitate. Governments debate priority. Meanwhile, cigarettes remain cheap and accessible everywhere. There's also an ethical dimension that makes some people uncomfortable. Are we removing choice by eliminating the ability to feel nicotine's effects? What happens if someone vaccinated decides they actually want to smoke? Their autonomy gets chemically restricted. Critics argue this crosses a line, that addiction treatment should empower decisions rather than remove options entirely. Supporters counter that addiction itself removes choice, that the vaccine restores freedom by breaking chemical dependence. Despite everything, progress continues. Newer vaccine formulations show improved antibody persistence. Combination approaches are being tested, pairing vaccines with behavioral therapy for better outcomes. Some researchers believe we're only 5 to 10 years from a commercially viable product if funding holds steady. What makes this fascinating is the shift in strategy. For decades, we've fought addiction by targeting the brain, trying to suppress cravings or replace the drug. The vaccine flips that approach completely. It doesn't care about your brain chemistry or willpower. It just stops nicotine from ever arriving at the party. Smoking kills 8 million people every year. It's the leading cause of preventable death worldwide. Traditional methods help some, but relapse rates remain devastatingly high. If a vaccine could even moderately improve those numbers, the impact would be enormous. Millions of lives extended, healthcare costs reduced, families kept intact. The science is real, the potential is undeniable. Whether it becomes the breakthrough we need depends on solving these remaining puzzles before momentum fades. The next few years will show us if immunity can finally outmaneuver addiction. Right now, someone you know is trying to quit smoking. Statistically, they'll fail within the first week. Not because they're weak, but because their brain chemistry is working against them. The nicotine vaccine won't solve everything overnight. It won't fix the behavioral habits, the social triggers, or the hand-to-mouth motion that smokers crave. But it could remove the one thing that makes quitting feel biochemically impossible: the reward. When your brain stops getting what it expects, patterns break faster than you'd think. This isn't about forcing people to quit. It's about giving them a tool that actually matches the scale of the problem. Addiction rewires your neural pathways at a molecular level. Maybe the solution needs to work at that same level. The question isn't whether we can create a nicotine vaccine anymore. We already have. The question is whether we'll refine it, fund it, and deploy it before another million people die from a habit their brain won't let them escape. The clock is ticking, the science is waiting. And somewhere in a lab right now, researchers are one breakthrough away from changing how we think about addiction forever.